Hello everyone and welcome back to our HCI certification training course. This is a continuation of our section 8, and in this session we will be demonstrating to you how to implement interface-based VLAN assignment. So this is our second lab. You remember in our first lab we showed you how to create VLANs, either creating single VLANs or creating multiple VLANs using the batch command. You can see that this is the topology that we are using. We have two switches. We have switch 1 and switch 2, and this switch 1 and switch 2, they are connected on Ethernet 003. We also have PC1, PC2, PC3 and PC4, which are connecting to the switches. PC1 and PC2 are connecting to switch 1, and you can see that switch PC1 is in VLAN 100, PC2 is in VLAN 200, PC3 also in VLAN 100, and PC4 in VLAN 200. So from the beginning, we know that this one will be one broadcast domain. So all these switches should be able to communicate without any problem if we haven't configured any VLANs on the switch. If we just have one VLAN, which is the default VLAN 1, then all these switches, all these devices will be able to communicate. PC1 should be able to ping PC2, PC3, and PC4. But once we implement VLANs, now PC1 should only be able to communicate with PC3, and PC2 will be able to communicate with PC4. So we'll have created two broadcast domains using the two VLANs that we've configured on these devices. So in this session, we are just demonstrating to you how to configure interface-based VLAN assignment. And remember, we mentioned that this is the most common used method of assigning VLANs to user devices. This is the most common, this is the most used method of VLAN assignment. But in the later sessions, we will be demonstrating the other methods. MAC address based will be demonstrated in the next session. So we will have this topology, and we need to create the VLANs on these switches, VLAN 100 and VLAN 200. We also need to configure these ports. Remember, these ports are connecting to the user devices, so we should be configuring them as access port. So the ports connecting to PC1, PC2, PC3, and PC4 on these different switches should be configured as access ports, and then the port connecting the two switches should be configured as trunk port, and we should allow the two VLANs 100 and 200 to be able to pass through the interlink between the switches. And then we should go ahead and test the connectivity between the different devices. So if we start by verifying the configurations on the switches before we dive deep into the interface-based configurations. So if I go to switch 1 and I display VLAN, you will see that we only have one VLAN, and that one VLAN is enabled on all the ports. If you check switch 2, we expect the same. Display VLAN, you will see that we only have one VLAN, VLAN 1, which is the default VLAN, and you cannot delete this VLAN. We have configured these devices with the IP addresses PC1, PC2, PC3, PC4. For example, let's check PC1. So PC1, you will see that it's configured with 192.168.100.1. PC4 is configured with 192.168.100.4. So they are in the same subnet. So it's a broadcast domain. We should be able to communicate without any problem. So if I ping 192.168.100.2, see that we are able to ping .3. Let me see. .4. .4 we are able to ping. Let's check .3, which PC has .3. This PC, we check the configuration, it's 192.168.100.3. if I ping from here, ping 192.168.100.1, we should be able to ping. Let's ping .2, we are able to ping, and then .4 we should be able to ping. Let's go back to PC1 and we ping dot 3, we are able to ping. So we are able to ping. Maybe it was not just learning, it was just learning the MAC addresses for the different devices. So sometimes you need to lose some packets before the MAC address is populated with the information. So you can see that we are able to ping from PC1, PC2, PC3, PC4. So it's one broadcast domain. If we have a broadcast packet coming in, it will be broadcasted to all the hosts on the network. Again, we mentioned about the MAC address table. So you can check the display MAC address table. And you see that we have the MAC address table, the MAC address, the VLAN. So they are all in VLAN 1, the default VLAN. You see the ports, the type is dynamic, and many other details that you can check when you display the MAC address table. So now let's go ahead and configure these switches so that we bind these ports to the specific VLAN, the default VLAN. We also configure this port as a trunk port and allow all VLAN 100 and 200 to pass through. And then we will test the connectivity to check whether we have been able to create subdomains or to create two broadcast domains of VLAN 100 and VLAN 200. So those PCs in VLAN 100 should not be able to communicate with the PCs in VLAN 200. So we go back to, let's check the configuration. So the first step, we need to configure the host name. We also need to create the VLANs. This one we already demonstrated in the last session. You can either create one by one or you can use the VLAN batch command. So these are the configuration for switch 1. Let me apply the configs for switch 1. And then switch 2. So for switch 2, I will apply the configs. Finally, we need to do the configurations for the VLANs. So we need to do the interface assignment. We need to configure the access port and trunk port. So the first thing that you need to do, you need to be in the specific interface that you want to configure. And then you need to configure the link type. The link type specifies whether the port should be access, only one VLAN, or a trunk, or a hybrid. So when you run the port link type, you can either configure that port as an access port, a trunk port, or a hybrid port. You will have the three options that we've discussed. So port 1, this is connecting to PC1, will be configured as access port, and this is how you define the default VLAN. So this is the default VLAN 100. Use the command port default VLAN. So this one will be an access port, and it will only allow VLAN 100. And then we have the second interface, same process, port link type, access, port default VLAN 200. So this one will only allow VLAN 200. So we've configured the two ports as access ports, and then we need to configure the trunk port. So you configure port link type trunk. So you have made it a trunk port, and then this is a very important command, port trunk allow pass VLAN, and then you give a list of VLAN that should be allowed to pass on this trunk port. Remember, you need to give all the VLANs that should be allowed on this trunk port. If you forget one of the VLANs, then you will spend a lot of time troubleshooting. So same configuration have been applied on switch 2, and then we can do the testing and verify that we have communication between hosts in the same VLAN, and no communication will happen between hosts in the different VLANs. So for switch 1, I'll do the configs, paste the configurations, and then for switch 2, we'll also paste the configurations. Now, if on switch 1 I display VLAN, if I run display VLAN, we'll find that we have two more VLANs. We have VLAN 100, and these are the ports that have been configured to allow that VLAN. We have the access port, Ethernet 001. We also have the trunk port, Ethernet 003. We also have VLAN 200, and you see that VLAN 200 has been bound to Ethernet 002 and Ethernet 003. On the other switch, if I also run the same display VLAN command, you will see that we have VLAN 100 and VLAN 200. So this one confirms that we've properly configured the VLAN and we've bound the ports using the interface-based interface, because we have specified the interfaces that should be in given VLAN. So we call it interface-based VLAN assignment. So now with this, if I try to ping .1, you see that we are able to ping .1. Of course, .1 is the local. I need to ping .2. .2 we are able to ping from PC1 to PC3, which they are in the same VLAN. So that is a broadcast domain. And then from PC1, if I try to ping PC3, you see that we cannot ping PC3. If again I try to ping PC4, you will see that we cannot be able to ping PC4. On the switch, if I display MAC address table, of course we've learned these two MAC addresses as of now, and you see that we have the VLAN now defined. It's VLAN 100, not VLAN 1 as it was before. On PC2, if I try to ping .4, you see that we can be able to communicate, because PC2 and PC4, they are in the same VLAN. So they are able to communicate. If I try to ping PC1, again, we are not able to communicate because we are in different broadcast domains. And that's why in the next subsequent sessions, we'll be discussing about inter-VLAN communication. How do we achieve inter-VLAN communication in such a scenario? So that if, for example, this is finance department, you still want it to access the IT department. So we still need to have inter-VLAN communication between users in different VLANs. So again, it's very straightforward to do the interface-based VLAN assignment. This is how you do it. You configure the port link type, either access, trunk, hybrid, and then for the access, you need to define the port default VLAN. For hybrid, for trunk and hybrid, you will need to configure the port trunk allow pass VLAN, and then you specify the list of VLAN that should be allowed to pass. And you can use the command display VLAN to verify that you have connectivity between those devices in the same VLAN and you don't have communication between devices in different VLANs. So this is it for this lab simulation. I hope you will take time and do the lab so that you understand how to implement interface-based VLAN assignment on Huawei switches. Thank you so much and see you in the next session.